Everyone, thank you for joining us today at the Avro Venture Studio, both remotely and also in person here at the studio. We're really excited to have this discussion with Brian Zetlin. I'm Regan Hinchcliffe, the VP of Public Engagement at Avro, and Avro's on a mission to pioneer breakthrough aerospace technologies that solve critical global challenges, strengthen Canada's sovereignty, and position Canada as a world leader in innovation. Brian Zetlin is an aerospace and systems engineer, an educator, and professor with a distinguished career that includes working on NASA's iconic Canadarm project, and he's now with Solis. And Solis is on a mission to provide persistent, global, scalable energy from space with space-based solar arrays. So really excited to have him on here to talk about his career and his current projects, and also just aerospace and energy and automation in general. I've been with Avro since about May, and since then I've been on quite a journey and been meeting quantum physicists, people that work at NASA, SpaceX, Blue Origin, Axiom Space, so many cool people throughout my journey. I'm very grateful for it. And one person in particular I'm extremely grateful to have met is Brian Zetlin. He viewed my LinkedIn profile when I was out at the cabin, and I remember seeing his name, and I saw his experience, and I added him immediately, and we immediately had a conversation. And then we met, and now we're collaborating together, and really excited to be speaking with him. He's already taught me so much about the industry, and very grateful that he's come to my life. Brian, I guess I'll let you take the floor there.
Welcome and greetings to all of you. I hope you're all young and fit, because you'll be standing there for an hour and a half. And I want to thank Reagan and Avro in particular. Yes, we did meet indeed over LinkedIn. The reason I connected with him wasn't his pretty face. It was that I saw Avro, and I'm old timer, as you all can see. And I still remember when Avro was building warplanes, in particular bombers. And then in one of its final incarnations, they built a jet, the Arrow, Black Arrow, that exceeded anything that we were building in the US. This is when I was a child, but I've never forgotten that. So when I saw the name, I thought, hooray, another great aerospace company has come back to life. That's how we met. And I have been impressed, consistently impressed, by the chief quality, I think, that anybody who wants to get into this kind of engineering needs to have, and that's enthusiasm. You don't necessarily have to get great grades to be a great engineer, or for that matter, to play any role in space or aerospace engineering. I will, in a moment or two, I'll tell you how I literally fell into my career. For the time being, let's just move on. Regan has agreed to be the moderator. I'm a professor, and I talk too damn much.
Yeah, we're going straight into your career now, so I think it's a good segue. You were involved in projects like bringing the Canadarm into space, working with controlled exports. When you were at NASA, you worked at Blue Origin, Axiom, other transformative aerospace projects. So let's share with the audience some of the inspirational things that you've accomplished in your career, Brian.
All right, we'll back up a few years before Canadarm. When I was a young man, I used to do a lot of running and biking. And one day I fell off my bike, and as in fell off, and wound up with 9 months in a hip-to-toe cast, during which I could not walk without crutches, drive, or do any other form of moving around. My next door neighbors were kind enough, after I got over the initial shock, I was in the hospital a long time, to invite me over to play cards. And what I didn't know at the time was that most of his friends who we played cards with were Rand Corporation. And for those of you who are not familiar with them, they're still around. Rand Corporation is, in my view, and I think in many others, the premier think tank in the world. There are others that are on a par, perhaps, like Stanford and so forth. But again, in my view, and I think in the view of most people in engineering and the sciences, they're tops. I had no business being there, but they said, look, since you're effectively paralyzed from the waist down, we're going to set you up, give you an office at UCLA, and you're going to start an arms control center. This is not the kind of arms control with the peace sign. This is tracking nuclear and other types of weapons, including satellites and rockets. And so we had mainframes, but we didn't have anything like desktops. So I proceeded to make myself a sort of instant expert. And the more I got into it, the more I realized that this is pretty new field. And so I set out to become a by God expert in particular satellites and rocketry. other areas as well, radar. And from that came a chance meeting with a guy who appointed Dr. John Clark, who appointed me to the FCC. I was 20 years younger than everybody else there. And from that came an invitation to a meeting at Los Angeles International Airport, hosted by an aerospace executive. And they asked me to come and talk about the then burgeoning field of geostationary satellites, which today basically handle just about everything up there that's heavyweight data. I found myself in a room at the airport with 5 men. Regrettably, there were far fewer women in aerospace in those days. I was asked to give a 1 hour lecture, a 1 hour talk about the economics and the technical challenges of creating a geosat to hover over South America. Nothing like that had been done. It eventually became Pan Am-Sat. I spoke for an hour and the questions were quite intelligent. I was introduced to John and Eric and Pete and so forth, and another hour passed. And I mean, we didn't have lunch and it was getting time for dinner. And LAX has that great big spidery looking restaurant in the middle of the airport. So they said, let's go on over and have some drinks and have dinner. And during the beginning of dinner, when we were all toasting each other, said, do you know who you've been speaking to? And I just knew the first names. And this was the crew of Apollo 12, Dick Gordon and Alan Bean and Pete Conrad being the most famous, the guy who raced Corvettes around and stuff like that. From there, 10 years later, Dick Gordon was best man at my wedding. And there's a part 2 and part 3 about that. But from that evening on, I was invited to more and more programs, symposia on the strength of my FCC connection and RAND. We'll leave that alone for now, and let's fast forward to Canadarm. In the early days of shuttle development, actually beginning in the 70s, most people understand that the first shuttle flew in, I believe, 81. The program was managed by a NASA great, a man named Bo Bamick. I knew Bo personally. And there's another guy there who came from Northrop named Ron Kubicki. And Ron was dual citizen, which I don't think had much to do with it. But Ron was charged by NASA with getting over the export control problems that we had even with our best neighbors next door. And so Ron came to me and he said, you're a sneaky, clever son of a bitch. Help me on this. Because I had some experience at the State Department. So we worked on it. And by God, it was the State Department that made it happen. We got it authorized and approved and then began the process of integrating it. And I have to say, McDonald Detweiler was one of the principal teams. You folks had done a lot of the integration work in anticipation of our being able to install it. They're very complex. We're not going to talk about Newtonian effects in space, but they're very complex mechanics about operating any system in a zero gravity environment. It's nothing like easier. In fact, it's much more complex in terms of leverage and so forth. I'd rather not do the litany of who I worked for and where I worked and all of that. I'll just go through the high points.
Yeah, that's great, Brian.
Yeah, and also adding that I have a lot of experience in nuclear systems and as well as general energy. In 1982, I was asked to join a brand new firm called Science and Engineering Associates. All the other people in the firm came out of the National Laboratory System, and our chief business was designing systems to protect satellites, rockets, and aircraft from nuclear effects. Chief among them, EMP. And for those of you who don't know what that is, electromagnetic pulse is an effect produced by very large explosions, which disables or destroys all electronics, period. And we were terrified, as were all the great powers, of these devices. This small nuclear weapon that detonated in space doesn't hurt anybody, but it stops all aircraft from flying, all computers from operating, medical systems. And so we became first and foremost in that field, working through the laboratories and especially working through Department of Defense. Along the trail there, I was chief troubleshooter. That was actually the title on my card for Boeing Military Airplane Company. I also worked on Hughes satellites and Boeing satellites at the time. Went on from there to form my own company, Seattle Scientific Corp, which I closed down 20 years to the day after I opened it. And during that period, I worked and consulted to the Russian Space Agency, JAXA, the Japanese Space Agency, ESA, NASA, and even the old Canadian Space Agency. Also worked on Atlas rockets. I worked on the RS-25 engines Alas, I was too young for the F-1s, but the RS-25s were the shuttle rocket engines. And during that period, picked up a rep for being a good program manager. Now, going back into Reagan's experience, I want to add that there's some other qualities, and this has to do with employment, but it also has to do with having a satisfying and fulfilling career. You can have plenty of doubts about your abilities, and professors like me will beat that out of you. If you have promise, we'll get it out of you. You need energy and you need enthusiasm, and you need to ask yourself, am I a good connector of dots? Do I have the combination of logic, native intelligence, observational skills to be able to make leaps of logic, to connect things that are otherwise not there? That's basically my chief talent. And also the sneaky son of a bitch stuff, which I've been called more than once. During that tenure, I also served on the Federal Aviation Administration as what's called a designated engineering representative. My job was to help design systems to protect rockets and aircraft from lightning strikes. I've also worked on human spaceflight. Let me get to part 2 of the astronaut story. Shortly after Dick Gordon was best man at my wedding, he came to work for me. The reason was that in the United States, even astronauts retire on military pay. And even in those days, he was captain, and military pay was about a third of what it took to lead a decent life. His wife called me and said, help. I said, sure. And he worked for me for several years. I don't think we ever did any technical work. It was mainly politicking and working government issues. And Pete Conrad was along for that ride. And Pete and Dick and I went to Dan Golden in the 90s when he was the administrator at NASA. Of course, they were both friends, and proposed a solid rocket system, which he laughed out of his office, and rightly. But still, being a part of that all those entire communities, subsequently led to working for a brief time at Blue Origin and getting a very deep sense, because I've hired something like 1,200 people and run a half a dozen companies, of why a literally bottomless pit of funding and a couple of thousand brilliant engineers could not put a rocket out, while SpaceX was putting out tens and then hundreds. That informed, and it still does inform, my experience. Most recently, I've just come off of a stint at Axiom Space, which is based in Houston. And my title, which was a NASA title, was Senior Program Manager, Lunar Terrain Vehicle. And I'm sure that you've seen antique films and more modern ones of rovers. My chief charge, which is to act between the builder of the rover, Axiom, and NASA, and this is the NASA program manager, was to integrate the suit with the rover. And for those of you who are interested in manned flight, but now called human space flight, thank God, learn a little about what's called HITL, HITL. That is human in the loop. That's the process by which engineers and scientists and physicists design systems so that somebody in a 500-pound spacesuit, albeit operating in low gravity, can interface with, on the real world, would be a golf cart. And the problems are immense. There are electrical charging problems, there are human ergonomics problems. It's also utterly fascinating. So now I'm going to shut up about my background, and I want to go on and talk a little bit about Virtus Solis. And I'm really pleased to see David Berger is here and Tom Jemison. Tom is on our board of directors, our industrial advisory board. You can look that up. And David Berger is one of the original members of the company. He's what you'd call in the executive team, the core team. He manages and handles government affairs, licensing issues, generally the entire political arenas that you have to travel into to work in space programs. He's also a very bright guy, 30-year mayor in Ohio, which in itself is an extraordinary accomplishment. And I'm delighted he's here. And maybe if there's time, he can say a couple of words. I was invited to join Virtus Solis in early 22. Came at a good time. The gentleman who introduced us was also one of Virtus Solis' original investors. In fact, he may have been the first one. And I'd like you to look him up, and if he'll accept you, hook up with him on LinkedIn. His name is Pablos Holman, Pablos, Pablo with an S, Holman. his title is Deep Futurist. And his little truck, as I'll have with people who call themselves futurists, because I think it's pompous, Pablos really does own claim to it. He's a brilliant engineer, but that's the 10th part of he's a true visionary. And he's brought up some very important technologies. And so he's someone that if you follow him, I think it'll be a great help in anything that you're planning to do. Verta's core technology and core purpose is to build a type of satellite which will be organized into vast arrays. Some people call them constellations, but in fact, the Verta satellites are connected to each other. There's some technological aspects of it, and I'll direct you to the website as well. The purpose of these satellites, which are about 1 meter square, is to convert photovoltaic power photons from the sun into microwave energy. Now, again, we're not going to go into a lecture about how photovoltaics actually work, but you take energy from the sun, you send it down to the ground on solar arrays, the same kind of little systems that run the light meter in your old camera, or the systems on people's roofs. And that produces, on a really good day, at the maximum efficiency, about 30% translated power. You can easily, with the arrays on a roof, you can easily power a house, easily, and sell energy back. We've taken another turn on it. And the two founders of our company, John Bucknell and Ed Tate, and I'm saying this with 40 years working around geniuses, men and women who are far better educated than I ever will be, and far better at their jobs, but I've had the privilege of working with them. These two guys, Ed and John, are among the brightest engineers I've ever met. And they're polymaths as well. They've got several different degrees. And between them, they've come up with the antenna technology, the conversion technology to produce energy that competes favorably with nuclear in terms of cost and with photovoltaic in terms of simplicity of operations. It surpasses them in several critical ways. Although its infrastructure is expensive, like a nuclear plant, it's also safely off the planet. So the typical vulnerability points for any type of ground-based nuclear power have to do with cooling or releases of toxics or radioactives. None of those are possibilities. Terrorist attacks are still a possibility all over the planet. It'd be very difficult for anyone to bring these things down. It also operates, unlike standard photovoltaic or wind, 24/7. So again, I'll send you to the site, but without going on about it, we have chosen a type of orbit that allows 3 of our floating orbiting arrays to cover the planet 24/7 with energy. The potential, and we do these calculations based on a formula, which I'll also put up for you, is for this system to provide enough electrical power to solve the planet's needs. And all of the planet's electrical needs. There'll always be a place for solar and on a small scale basis, but this is energy that will be distributed through existing utility systems and or standalone ground stations. I am deeply proud to have been asked to join this group. And I ask you all to take a look at this, if only to see whether or not it suits your interests. So I'm shutting up again.
What are some of the trends that are happening with our energy needs that Verta Solis is going to help really solve?
I'm going to put up something here before I put up the Verta Solis site.
Everybody has access through the newsletter, but it's also in the LinkedIn post. So you'll be able to see their LinkedIn and to get the website there. Yeah.
All right. You'll be able to see, I think, LCOE.
Yeah. Okay.
That acronym stands for Levelized Cost of Energy. It's an extraordinarily complex, basically it's an equation. It combines algorithms, and what it provides at the end result is an answer for, under XYZ conditions, what is the levelized cost of producing energy? And let's say the nuclear plant is producing energy at net 4 cents a kilowatt hour, which is very low. Or photovoltaic is producing energy at 45 cents or 50 cents, and those numbers can climb. We use those calculations, principally Ed, Mitchell, John, and a few of our other highly technical people use those to do the comparisons that allow us to actually understand the entire cost of producing 1 unit of energy. And some people use the term externalities. It's used in the financial market. For instance, How much does it cost to produce an ounce of gold or platinum? It costs XYZ. What about the environmental cleanup costs? What about the costs of rising labor costs? What about liability costs? What about damages or other exigencies that occur around the process? And LCOE was built by probably the largest utility organizations in the world and academia. Based on that, our designs stand up favorably to everything, including nuclear, which is generally much lower than fossil. But again, without the costs of decommissioning a nuclear plant. Let's talk about the evolution of aerospace and energy technology.
Before we get, and I think a good segue to get there is, what are the current challenges to be able to get these solar arrays in space with respect to the economic challenges, the tonnage requirements, things like that?
Good question. In the late 19th century, if a farmer wanted to get his product to market in central Canada, he had to have a wagon. And if he was lucky, there'd be a railhead somewhere in the vicinity. By the time you're done, the only real reason to have small farms was to feed your family. And industrialization and transportation changed all that. As a dear friend of mine says, who is one of the engineers who worked on Ariane, the space isn't going anywhere. We were. And the only way we could first explore and then exploit was to have transportation systems that made economic sense. In space, the number one issue, quite apart from safety and technology and what have you, is the cost for moving mass from the Earth's surface out. And there are a lot of ways to calculate this, but the most realistic numbers come from the Saturn era, the Apollo era, when we first put, well, Gemini and Mercury, but when we first started launching capable ships. In those days, it was around $600,000 a pound. It quickly dropped after the Saturns were no longer used, down into the tens of thousands, hovering around 80, 90,000. Sometimes they used kilos. And then in the later stages of early space, it got down on the shuttle and so forth. At space station, it was about 20 down to 5,000 using very large rockets. This is no kind of economical avenue to prosperity if you're just looking to open up Joe's hamburger stand in orbit. It doesn't work that way. And there's also a means of calculating all of the costs of putting something into orbit. So what we have now, skipping over 20 years, is with SpaceX, and probably in another 10 years or so with Blue Origin, and with Electron, the Rocket Lab people, Spoke, Firefly, we have the ability now to put stuff into orbit at far lower costs. And Musk is now talking about $500 a pound. And again, this is all dependent on something that never existed in space before, which was mass manufacturing. And whatever else may be said about Elon and the folks at Tesla or anyone else, Musk made one critical decision that Blue Origin failed to make, and that was to find the best people in the world and leave them alone. Not put in micromanagers, he's one, but not put in micromanagers who are managing to time and budgets. That's the death of any space program. That's not how we build stuff, and it's not how we can build it. The cost of getting to orbit is dropping. And our principal challenge at Virtus Solis, our principal challenge is working the economics of getting those thousands and thousands of monocoque satellites into orbit. Our vendor of choice, of course, will be SpaceX, but again, with the build out of other companies, I think there'll be more and more competition. And I believe our models will probably always use the Falcon series or something like them, but who knows in the future. So that's the number one factor. Number two factor is the technology. And it's interesting. Anytime you look at what's called first adopters, you'll see that they're typically people who don't really know anything about something, but they'll bet on it. Famously, Steve Jobs invented something, and he did invent the iPhone. Whatever anybody may say, he invented it, the core. He literally called it a solution to a problem that doesn't yet exist. And much of Apple's marketing effort was focused on the capabilities, not the technology. And that's what got them where they are. Are we building a solution for a problem that doesn't exist? Absolutely the reverse. One of the biggest problems, if not the biggest problem facing humanity, is energy. Now, anybody who goes into a science class in third grade learns that the sun produces enough energy on an area the size of New Zealand to power the entire planet. There are two issues with that. Who wants to give up an area the size of New Zealand and build a transmission system all over the world? So do you do distributed? One way or another, that cat needs to be skinned. And our system, as I said, provides worldwide power beam coverage 24/7. That is dependent, in turn, on the area that David, in particular, specialized on. How do we manage jurisdictions? How do we build customers? How do countries, which have differential needs and differential resources, buy that power? How will, for instance, Central Congo be able to avoid power when South Africa is paying 10 times as much per unit? That's the reason that Solis, as small and as we are and growing, is relying on the vertical model. This is the vertical monopoly model, basically. It's very similar to how SpaceX was built. The difference being was SpaceX had all the technology. What they had to do was figure out production costs. For us, our modeling and simulation is first rate. It's as good as anything I've ever seen at IBM or RAND or NASA for that matter. And we're very fortunate in having that, our core technical team. But the business of supplying power also means getting it from place to place. Yeah. Vertus's ground stations will be on average about a square kilometer, probably 3 or 4 times less surface area than is required for standard photovoltaic. And I think Regan wants me to move on.
Yeah, no, that's really exciting stuff. I appreciate that, Brian. Let's segue into the evolution of aerospace technology. Spend 5 minutes on that and just let's talk about more your experience, where you think we're headed.
Okay, I want to start that. In the days of early space, can anyone here name the rockets that were used for Gemini or Mercury or the Russian rockets? Does anybody remember the names of any of them? No? Agena, Atlas, Delta? No, the reason you can't name any of them is because we, even though we weren't the first to space, we built the Saturn rocket. This was on John Kennedy's statement in '63 that we're going to the moon by the end of the decade, and we did it. We landed in '69. The entire reason that the space program was saved from the depredations of Congress, who immediately, particularly people who opposed Kennedy, wanted to gut it of money, was the appearance of the astronauts. And the people at NASA who were in charge of public affairs knew that and understood it. And most of you were not even born in those days. But every day, as the programs began to expand, we saw pictures of the astronauts and their families. We saw the first incredible photography from space. We watched the early empty Apollo ships go up. But all the time, there were those fantastically cool looking suits and the gold helmets and all of the trappings of space. And that integration of media and public affairs and having the government support a program that was initially wasn't thought to bring any benefits. All of this, in view of the arms race, made it absolutely a slide to get the Saturn program funded from beginning to finish. After that, who can remember any manned space after 1975? That was a trick question. We did go up again, obviously, in the shuttle. And the shuttle's original purpose was to move things, not people, into Earth orbit, which it did very well. The Hubble telescope was put up there. Many systems were put up there. And at first, the shuttle astronauts were on TV all the time. And there were pictures of people releasing a bubble of water into zero grav or people's hair standing on it. And it kept the interest up. But in fact, the shuttle was a military program. And one of the realities of being involved in aerospace is understanding the technical and economic requirements of human spaceflight versus everything else. Today, we would never build a manned shuttle. There's no reason to. We've got robotic systems. The Russians, the Cavants, the Progresses, they're robotic. There's still issues, but the cost of putting a human being on the nose of a rocket can sometimes be equivalent to the entire cost of developing the rocket, because life support systems and safety systems have to be integrated into all the ship's other systems. They're very power intensive. I believe that the next generation of spaceflight, human spaceflight, will consist of some necessary missions, even regrettably military missions, but the rest of it will be just regular old engineers and manufacturing people going up and doing things like building habitats on the moon and Mars. We'll get to Mars. Probably I won't be alive, but we should be able to get there pretty damn soon. And now that I'm who I am and where I am, I also know that we can do it, which is nice. It's a very satisfying feeling. We'll be building moon habitation very quickly. I'd say within the next 3 years, we'll be sending machinery up to the moon. There are huge challenges, again, in the costs of putting people rather than simple machinery up there, but it's going to need people to do it. So if you're interested in the field in general, learn something about what it takes to put people on board ships or in spacecraft. If you're not particularly interested and you're more interested in technology, it still doesn't hurt. It still won't hurt you at all if you want to make a career in space. The Lunar Industrial Base, Reagan's done a superb job of organizing some of our thoughts and categories. The Lunar Industrial Base is going to occupy at least 100,000 engineers. At least. This is globally. Hopefully there'll be a good contingent from CSA or the private sector in Canada, probably from Avro, if I know my companies, and Bombardier and de Havilland and others. But that Lunar Industrial Base is going to be the big focal point. And
why is that, Brian?
It makes sense. It makes economic sense. Does anybody know why Mars is red?
The dirt?
Yeah. Why is Mars red? What's the cause of that color? It's rust. That's all it is. The surface of Mars is oxidized ferrous metal. That's why it's red. If you bake oxidized metal in a non-oxygen atmosphere, it produces oxygen. We'll be able to produce oxygen easily on the surface of Mars once the machinery gets there. Does anybody know what the surface of the moon consists of?
Helium-2.
A thimble full of helium-2 would cost more money running a province in Canada. Yes, there is helium. It's helium-3, but the production of helium-3 is a part of the manufacturing process. The surface of the moon is dust. It's finer than flour. It's micrometer, and some of it nanometer, is ground up meteorites. This is 2 billion years of rocks coming in from space and smashing each other to bits and fragments. Under the craters that you see on the moon today are thousands of other craters that were obliterated. That dust is iron, nickel, and quartz. We're not ever going to run out of iron on Earth, but as you drill into the surface of the moon, there are materials that can be used to make oxygen, to make hydrogen. There may be what's called juvenile water on the moon, which means water that's never been exposed to the surface. And there are obvious markings of water ice on Mars. So when we get there, we'll be people who, for the very first time, come across the plains of North Dakota. Here you've got the richest soil, or Alberta or Saskatchewan, right? Have the richest soil, but how are you going to irrigate it? How are you going to exploit this resource? And the Lunar Industrial Base will be the focal point for that. I predict that we're going to see Rio Tinto, which is you folks, and Anaconda, and every one of the great mining and extraction companies, global extraction companies, with bases on the moon.
That's amazing, Brian. And the other element, the moon with its low gravitational pull, is also going to allow us to build the ships to go to Mars. And
For those of you who are introduced, have ISAM, which is in space assembly and manufacturing. Manufacturing in space is a fool's errand. It will probably be very necessary on the surface of Mars, where you've got a little bit of gravity. I think it's 12.5%, about a sixth gravity of Earth. But manufacturing in space presents ridiculous logistics problems. Assembly is another thing, and Reagan was right to point out the great Mars ships will be built in orbit. We'll be sending up bits and pieces, just like we did for the space station. And parts of those rockets that go up, Artemis, Starship, what have you, will be used as fuel tanks to prepare, and habitation units to prepare for these extreme long duration voyages. So assembly in space and assembly and orbiting around the moon for these great projects will become a huge industry with opportunities for any kind of employment.
yeah. Oh, that's great, Brian. Thank you. That's paints a really good picture, an exciting future as well. So we have Gate here with researchers and students and graduates, and really want to lean on your experience and speak to them about education, mentorship, and just provide some wisdom to help these individuals with their careers and advancing their lives in their respective fields.
What I want to do is speak with you, not to you, not so much as a teacher, which I've been fortunate enough to do. I actually teach space mission analysis and design and spacecraft systems engineering, which is great fun for me and eye-opening sometimes for my students. But I want to go back to my experience at the airport all these years ago. By sheer chance, I fell into the company of those people. The reason for that was that a small group of people trusted me enough to give a young person the chance to work at RAND. I wasn't there very long on a limited basis, but it gave me the basis for credibility. And all my life, we all hear it's the people it doesn't matter really, and nothing else matters.
Isn't luck when preparation meets opportunity?
Of course, and that's well said, but it's not really the people you know, it's the people who know you and trust you. And that's a very small circle when you're young. This isn't like being a rock star. Mentorship doesn't just happen. For those of you who are already adults and embarked on your career, as well as for those among you who are looking for a new career or still studying, go to the people who teach you or who respect you or like you, and not find out. And what intrigues you about them is what you should ask them about. For instance, let's say when Reagan and I first met, I said, Avro, and tell me all about it. Within 2 minutes, I knew that he was sharp. I knew he had remember my enthusiasm and energy, but I also understood that he was embarked on the voyage of discovery. A couple of weeks ago, I was talking to a friend and colleague who is chief of aeronautics at NASA, Stephen Hirshhorn. And we got to talking about how we got in this business. And he said, I'm not sure how to put this. He said, I literally cannot stop learning. He's 60 something. And he said, every time something catches my eye, I'm like a magpie and I go chasing it. And I said, that's the discovery. And he says, yeah, Brian, that's exactly what it is. The world is composed for the most part of explorers, the people who go out there and find that broad expanse in central Canada or the mountains or whatever, and then the people who come and settle it. Some of us are explorers, some of us are builders, some are, if you're lucky, you're both. Mentorship, this isn't about going to the professor every couple of days in his office. This is about finding people, cultivating those relationships. This isn't about manipulating or exploiting people. It's going to them and saying, look, I don't know jack about this, but I'm fascinated. Do you have a little bit of time? And the smart ones will say, yeah, buy me a bottle of wine and I'll talk my head off. It really does work like that. The people that you like and trust in your everyday life, ask them about things that are interesting to you and perhaps interesting to them, and maybe they'll steer you to somebody. I believe in this. I've hired between 1,200 and 1,500 people in my career, many of my own students, I was fortunate to say. And that curiosity and the willingness to take the risk of connecting with people who may tell you to get lost, it's essential. Really read my lips on this. You have got to know people who can come to learn to trust you.
A good element of that is showing vulnerability.
Yeah.
And asking for help. People typically want to help. If we hold it close to our chest, though, and don't show that vulnerability, I don't think you really ever give that opportunity for that professor to acknowledge that this person may be a good fit.
You all are bright people. You wouldn't be, you're here because you're bright people and curious. This is precisely true. Vulnerability is a big problem for a lot of people. Most of my life in private situations, I'm very shy. I know I don't sound like it, but I have minor panic attacks and all of that. I've overcome it because I've lived so damn long. And you can't really display that kind of behavior. But I finally got over my unwillingness to say, could I ask you a big favor? Or could I ask you to help me on something? I don't know how to do this, or I want to learn. For some people, pride just prevents them from doing it.
Exactly.
So, I don't want to go on and on about all the platitudes, apply yourself, and all of that stuff. You need to think of yourself. We all need to think of ourselves as art or engineering works in progress. The stronger you build your foundation, which consists principally of the people who know you and trust you, employers, employees, friends, family, the more easily you'll be able to handle larger or more responsible roles. A very quick point about this. We joke about people wanting to be a manager, going to McDonald's and somebody wants to be a manager. There's nothing wrong with that. But in aerospace in particular, counting coup in aerospace consists of being told by your manager that you now have direct reports. And young Joe or Janice goes, goody, I've got somebody who works for me. This is somebody I can push around and take out the garbage and all that stuff. And when you get up to the stratospheric heights, people like David, he's managing a city, got a lot of people who report to him. You either do it really well, which consists of understanding how people work and function together, or you become lord of the estate, or you become a feudal lord. There are many brilliant people who want nothing to do with people management. And you'd see that at Boeing and Lockheed. And now he's got 4 engines. Some of these people say, I'll quit. I don't want to find out about somebody's divorce. I don't want to have to fill in. I don't want to do that. I want to do my work. So you need to look at yourself and think about, are my aspirations fame, control, power? It's important to be introspective. It really is important to maintain that. And going back to education, I was a terrible student. Oh, terrible student. Look, I went to school I started in the late 60s. I went to UCLA, a public school in the United States. Whenever, and I had a lot of security clearances, top secret and above that. And when they question you for these clearances, one of the questions they'd always ask you is, have you ever used illegal substances? And of course, when I was young, I lied. And then finally, when I was 35, I said, no. I was being questioned, and this was for a nuclear clearance. And the questioner said, sir, have you ever? And I said, if you can find me one human being who went to a public university in the 70s who didn't get high, I'd like to know about it. And times change, mores change. Now we're looking at terrible shifts in the United States and in that area. But the purpose of education is to open up the world, not to close it. So I know now you've got to do this and that to get your engineering degree, or this is your curriculum and you've got one elective per year, or however you want to do it. It's very constraining. It's all good intentions, and there's nothing wrong with the people that they produce. But there's something that I shared with Regan, and I want you all to think about this, particularly if you're going into engineering. The world is now producing about 200% more software engineers than we're going to need. It's probably well over that. India produces more software engineers than the rest of the world combined, and they're damn good. But AI is going to scoop that up too. And you'll have a smaller and smaller, more brilliant, more concentrated energy and focus in software engineering, particularly in software research, machine learning, what they're now calling AI. If you're interested in software engineering and you think you'll make a damn superb software, by all means, go for it. For everyone else, and this is what I tell all my kids, you want to be a software engineer, be a mechanical engineer, because you need software engineering, but make that a minor. Go into an area where the scope of work will always remain open. Electrical engineering, industrial engineering, systems engineering like me. That's how I learned my trade. Don't get so narrowly focused. This is a tragedy in the 80s and early 90s that so many people became Microsoft certified experts, and these people never progressed. What are you going to do now? Are you going to work on desktops at the local computer shop? So open your manifold here. Take a look at all your options. And again, if you think you're going to be on a par with the top electricals or structural or what have you, engineers or scientists, go for it, focus on it. But if you're just brilliant in general and curious, get a double degree or have a strong major and minor. So now I'm going to shut up about that. Reagan, lead me on here.
The importance of collaboration between government, academia, and private enterprise.
See, that's why I rely on you young people to keep me from going astray. Ecosystem. What's an ecosystem? An ecosystem is any group of things, living things, that are tied to each other, whether we like it or not. There are eco-cycles, eco-disasters, eco-technologies, even things like composting and what have you. Right now, and for the foreseeable future, there are two issues having to do with space environments. One is composed of the damage that rocket launches are doing to the atmosphere. 30 years ago, who cares? It would take 100 times more launches to appreciably damage the atmosphere. But the fact is that fossil fuel and basically liquid fueled propellants and solid fuel propellants contribute immense amount of bad gases into an environment where they don't normally exist. The upper atmosphere, where the bulk of propellant is expelled, is not home to a lot of hydrogen or sulfides. It's not home to a lot of aluminum particulates. It's not a natural home. And there's no such thing as introducing a new element into an established ecosystem without causing damage. It doesn't happen, and we're seeing evidence of it now. Similarly, the moon's got something like 120 pieces of space junk sitting on it. Mars is catching up. It's laughable right now to think about that, but down the road, we'll be introducing bacteria into the Martian climate. There are anaerobic bacteria that can live without oxygen. There are bacteria that can live after being frozen, extreme temperatures. There are other kinds of organisms that we try very hard. We try to sterilize everything, but still, we are going to be introducing new chemicals, new processes. We don't really yet know what mining will look like on the moon, what kind of systems we'll have to develop. Understanding and learning about environmental issues is going to be an important part of comprehending and understanding space ecosystems. Then there's the economic ecosystem. And at Virtus, we've talked about this because our proposal for the future is to change the world's economy by providing universal, inexpensive power. That's going to have a ripple effect. That's going to put a lot of industries out of business or markedly shut them down. What, in fact, are going to be the results of mining on the moon? The first result will be we'll be getting materials to support our own life there. After a time, even perhaps even producing enough oxygen and water to have below ground habitats, sustaining habitats. The spacecraft ecosystems, swarm of satellites, I think their satellites in low Earth orbit and medium Earth orbit now comprise 2/3 of all the active satellites. This is one company up there. They're going to be introducing another 10 or 20,000 satellites for just that data system. In fact, I believe they just swallowed up Swarm, which was an early Canadian satellite data system. If you don't coordinate, then you just have a bunch of chaotic problems with interconnectivity. Now, having said that, we'll have what, 40, 50, 60, 70 data satellites. The Chinese have announced that they're going to put up 100,000 milsats, military satellites. And that's a fraction of what they intend to do in the future. China has announced that it intends to dominate space. They've said so. And they intend to do it by military means, also said so. So the space ecosystem is now going to consist of people with rifles facing each other and daring each other to fight first. It's regrettable, but having lived through the arms race, and in fact, having been an arms and weapons designer, I can tell you that once that process starts, nothing will stop it. How do we manage that? How do we create a space ecosystem that's managed by conventions and by treaties? There's been a lot of news now about the United States and other nations participating in the space analog of the law of maritime law. The United States is one of quite a few countries that don't subscribe to it because we feel that the law of the sea or maritime law constrain our ability to expand. But if you're Indonesia or anywhere, Cuba, what have you, what are your rights in space? Your rights are what you can put up there. If Cuba doesn't have the ability to develop a satellite or to put one up there, they got to piggyback with somebody else. So going back, the new space ecosystem is going to be composed of the same three parts that all terrestrial ecosystems are. These are industry, academia, and government. No space company or project in the world is independent of government support. The bulk of SpaceX launches are government programs. The bulk of Blue Origin's revenue for years to come will be the space station that they're hoping to build. Same goes for all of the major rocket suppliers. Your ability to work in any one of those environments improves by understanding the other two environments. You may be a customer. You may be someone who really does want to open up Joe's tanning salon in low Earth orbit. As costs come down, hotels will go up. There'll be commercial opportunities. The other side is if you're interested in defense applications, we're designing whole new generations of rockets. We're designing new propulsion types of propulsion. Dave and Tom, all the members of Solis, we've been discussing internally what means of propulsion will be most economical for us. So for those of you who have not heard of electromagnetic propulsion or what's called Hall effect engines, try to learn something about that. These are mere massless thrusters. They produce very little thrust, less than a kilogram of thrust, but in space, you can move a 20-ton satellite just fine with pulses of 1 pound thrust.
Mm-hmm. Yeah, I think I've seen a video of that for sure.
Extraordinary. That's one of the new emerging technologies. Been around for a long time, but building them cheaply. Another emerging technology, which goes back thousands of years, is solar sails. And just imagine a sail in space, a sailboat sail in space.
Yeah.
Thing is, what do you anchor it to? And the solar wind is there forever. Anything that's pointed at it will be pushed out. What can you do with solar sails? You can move tons of cargo. If you want to send, let's say, 1,000 tons of construction materials to Mars, why put them on 10 rockets? Just hook them up to a cargo carrying solar sail, drop them on Mars, and come back. It'll take a year or 2 years or 3 years, but you don't care. You've got construction projects. Again, solar sails are going to come, but it's going to need a lot of new thinking and a lot of new engineering ideas. The new space economy, about which another colleague who's also works with us to a certain extent, Karen Jones at the Aerospace Corporation. I recommend reading some of her papers, Karen L. Jones, but Dave has left us. That's unfortunate. Yeah. What she writes about is profitable utilization of space using improvements in economics. Axiom bet the farm on sending tourists to space. So those of you who are interested in microeconomics, their idea was that they would get billionaires to put up $50 million to go up to the space station on SpaceX rockets. So they didn't own any of the technology. They were just a facilitator. And they had 2 launches. The cost of designing to get them up there was 4 times. In other words, it was, I think, $200 million to put them up, and they're paying $50 million for the ticket. So this idea of space tourism based on billionaires there really aren't that many billionaires, and most of them don't want to give up 2 years of their life to train for a space mission. Will there be bulk tourism? Absolutely. Absolutely. Once we get the equivalent of Victoria Clippers, fast, affordable, going up into orbit, all kinds of things will develop.
I personally definitely want to go to space, and I know that someone put in their sign up that that someone else in, I don't know if he's in the crowd, but definitely wanted to go to space as well. Good on you.
Then let me do the third part of the astronaut saga. Going back, it seems like hours ago for everybody. Dr. John Clark put me into the FCC. Dr. Clark was the inventor of the Tyros weather satellite system, the first one in history. It's still running. He's long since passed, but he's a wonderful man. And the end of his career, he was the dean or the chancellor of the Florida Institute of Technology. What's important about that? Gordon and Conrad, astronaut guys, and as well as some others, we used to have these bullshit sessions all the time. What's next? And these all retire from space. And in 1999, I was making a lot of money. My kids were in college and doing really well. And I was unhappy. I was bored. My people managed themselves. They didn't need me around to tell them what to do. And I was unhappy at home. I just personally just unhappy. I picked up, and John retired, as I said. John Clark retired as the dean of Florida Institute of Technology, which is the astronaut school. That's the astronaut graduate school. I called him. And I said, John, and he said, I know what you're going to ask. And this guy knew me really. And I said, you know you don't. And he says, you're going to ask if you can get in. And I said, yeah. And the minute I said it, I realized I've done something that violated my own ethical code. But he led me right to it. He said, look, he said, you know me. He said, I love you. And if you want me to do this, I'll do it. You're in if you want to be in. I just want to ask you one question. Most of our astronauts in the system are former military. They're relatively young compared to you. And they have families and they're attending school here on limited military pay. And they're devoting their lives to this. Which one of those people would you ask me to give up their seat to put you in? I was so humiliated.
Oh, yeah.
And he said, I still remember him saying, I imagine your face is red. I said, John, I should never. He said, what? He said, I figured one day or another you were, you're like I am. He said, we're all crazy to get into space. Most of you, probably all of you, will have the opportunity.
Yeah, I agree with that. So we've got 8 minutes left. Let's get some questions and answers. If people want to put some questions into the comments, and then if Will or somebody that's in the main room there can go and type in any questions that people ask in the crowd, we can make sure to address them. All right, can you see the comments there, Brian?
I sure can. Here, let's see. This is Yuvam. Can you raise your hand?
Or no, you can see the questions within. Oh yeah, there you go. Yeah.
There we go. Okay. A lot of space tech companies surfacing within this decade. Everyone is in a chase, the sort of space race. Absolutely. Of course, space is big enough for all of us. What qualities or practices in a company do you think will make it stand out among its competitors? I'll say a couple of things, and I'll give you a brief answer, but I want to preface it by saying I doubt that 99.5% of the people in these startup companies understands the first thing about what it takes to field space systems. We talked earlier about the invaluable data proven by ground sensing satellites. Crops are managed, water sensors, weather sensors to protect against hurricanes. People are offering things like hyperspectral cameras, which is just a way of saying wide bandwidth. They're offering things like methane sensors. We just put up a methane sensor satellite. But none of them is offering a rocket. They all have to beg, borrow, or steal rides to do their prototyping. Right there, there's a competitive bottleneck. If you think that there is a good opportunity, go and talk to somebody who does hyperspectral sensing. Go and talk to the meteorological satellite operators and get a grounding in it. I've seen outlandish stuff. I get hit with it actually all the time. What it takes to be a winner in this sector, luck. And as Reagan says, you manufacture your own luck. Fortune favors the well-prepared, as they say. When you're going to market, and we talked a little bit about coming up with a solution for a non-problem, when you go to market, you need to understand the past, present, and future of what you're offering. I've actually tried to buy the Iridium constellation. Most of you won't remember it, but it was satellite phones, and they putatively could operate anywhere on the planet. I was FCC, and I knew it was bound to fail, and I wrote a couple of papers about it. 10 years later, they failed. $9 billion out of a $10 billion budget spent on dinners and airplanes going back and forth from DC, and $1 billion to fly this stuff up. And I see Letitia nodding wisely here, which is very encouraging. What are we going to need in space? We're going to need very good vehicle-to-vehicle communications, and we're still struggling with that. NASA has a thing called the Deep Space Network, which is optical, but very little good science has been done on cell phones between spacecraft. One of my clients, like most of them non-paying, but equity offering, is developing a lunar communication system, which consists of moving mobile cell towers. They're just little vehicles, and they talk to each other. They use radar to identify each other. They talk to each other and offer cellular communications on the moon. Nobody's developed these things yet. These are enormous opportunities because guess who's sponsoring most of them? The government. The government will be underwriting all of the early habitation on the moon. The government will be underwriting the new generation of medium-sized and geosatellites. And there are a lot of opportunities there for technology people, not necessarily deep technologists, but people who understand the relationship of various components in a system. I'd say the qualities you need are smarts, a willingness to listen, a willingness to let people who are smarter than you about that subject tell you what to do, and a willingness to keep your nose out of things like ordering people around and doing all that startup nonsense. Think long and hard about the objective. In systems engineering, we talk about the requirements. That's not the beginning of systems engineering. The first thing I teach my students in all of my classes is you design what is it we want to do, and then we design the spacecraft.
What's the problem that we want to solve?
Yeah.
Or we get lost in the features, but what is the problem? Yes.
And being in a hurry in the space business it's for fools.
I came from digital marketing technology and sales, so things move pretty quickly there. But I'm starting to get climatized to the spacing. But I think I'm bringing some speed to it too.
There you go. Yeah, I was actually the guy that tried to buy Iridium at the end of that. Okay, next question.
Anybody from the audience have any questions? Just type in the questions in the comments right here. Or you know what? Why don't you just take it off mute? You just take it off mute.
Hello, we have an audience question. Introduce
You just have to speak into the laptop.
Yeah, it was very nice listening to your talk, and I feel like I can listen to it whole day. Yeah.
It's very kind of you.
You could talk all day, believe me.
But I'm
Yeah.
not making your brain.
Yeah. So I'm working as a postdoctoral fellow in process system engineering in University of Regina.
Uh-huh.
Yeah. So what is Avro's approach on sustainable space exploration? If we consider as my research areas energy and fuels, is it regarding the fuel efficiency when we talk about the space mission, or making it economic, or how we can make it relevant to Saskatchewan, since we have a lot of biomass and we can produce hydrogen, which is one of the fuel for space exploration, and the kerosene grade, aviation grade kerosene. Can you comment on that? And
What's your name again? Yusuf, pleased to meet you. I think at last count, I lost count actually, but I think you just asked 7 questions.
I think he's talking about the fuel. Actually, Will, sorry,
All of which,
he was asking.
all of
Yeah.
which I direct you to the actual expert on those things. I can talk about him. It's right next to you on the screen. You need to be talking
Yeah.
with Reagan about that.
Yeah, and so the ICED program where we delivered our Mark I rockets, it includes a hybrid rocket system that the goal is to be more efficient with fuel. At the end of the day, fuel efficiency is the whole point is reducing the cost per kilogram to make efficient launches into space, to make it more economically feasible for specific type of projects to be effective. But there's other elements like autonomous systems and control systems and AI models that can actually expend the fuel at certain times based machine learning type of environment. So those are definitely, like our Mark II program is definitely going to have a lot of autonomous systems, other elements that the goal is to be extremely efficient with fuel. We're also working with another company on a 2-stage space plane to deliver payloads from a space plane, and they want to utilize our ramjet within their stage 1 system. The ramjets themselves there's less maintenance costs, they're better on fuel. And so the goal is bringing down the cost per kilogram, and that includes fuel efficiency, maintenance, efficiency in general. The goal is reducing the cost, being operational efficiency. With the rise in market demand for LEO and as Geo, Brian mentioned, but with LEO, like companies that stand out are the ones that are dropping down costs for operational efficiency. So, and fuel is a part of that.
Okay, the last 2 questions. Can we make it relevant to Saskatchewan since we can produce hydrogen from biomass that we
Gotcha.
have?
So the hydrogen element. So part of this is a hydrogen element. We're doing our engine maps on including hydrogen within this 2-stage payload delivery system. So hydrogen is definitely a part of that. So that's a good connection there for sure.
And the last question, what is the Avro's take on space debris? Can you comment on that?
There's a lot of space debris and junk up there for sure. I know a guy that wants to turn the ISS into a space junk repurposer.
I do work on that. Let's just do this from the physics point of view. All of you know that there's basically an infinite amount of space from the Earth's surface on up into the cosmos. For simple purposes, we have define orbits as being LEO, MEO, GEO, geostationary, middle, and there are also subcategories, and we also have polar orbit. So I want you to imagine a highway, one of your freeways that's 10 lanes across, all going in one direction. And the lanes if they were perfectly ordered, they would be in graduated higher and higher speeds. And in space, the low Earth orbit the velocities are the highest. They range from around 17,000 up to about 19.5, depending on what? The weight of the object. It's the stone on the end of a string, right? When you look at this highway, you're seeing X number of cars, back to back, front to front, traveling at fixed rates of speed in lanes next to each other. How is a piece of debris that's flying at the same speed and in the same orbital regime going to crash into another object? Now, if something is busted up, obviously the debris are going to have different weights and velocities. Some of it may even be accelerated. But what it's going to do is it's going to leave that orbital regime and go cross orbit. So there is a possibility of some damage from that. I do know that, and this is a bellwether for every government, immediately the government started talking about debris as a potentially serious issue. And there's some loudmouths on LinkedIn who, I won't name names, but go on about the sky is falling, we're all going to be killed. The real issue about debris has much more to do with natural causes. Again, you probably won't know about this, but there's a species of oxygen called monatomic. The oxygen that we breathe is O2. That's how our body uses oxygen. And monatomic is single atoms of oxygen. It's fairly common in LEO up there. And a monatomic oxygen acts literally like a rock or a grain of sand. And it pits glass, and it pits aluminum, and it pits forward facing surfaces. It's exactly like driving your car through a sandstorm. And almost all the research that we did at NASA and at Ames and Goddard Space Flight Centers had to do with micrometeorite holes in spacesuits, and it's happened. The shuttle, dozens of holes, micrometeorite. They didn't go all the way through, thank God, but tiny stuff. And forward-facing damage from monatomic oxygen. That's the real orbital debris issue. Now, what do you call debris? A satellite that runs out of gas may be able to persist in its orbit for tens of or decades and more. Most don't. So they come out, and we're now talking about planned deorbiting. The big project is deorbiting the space station, which I believe to be an act of suicidal idiocy. But the big guys, the Boeings, the Lockheeds, and the Northrops, have already gotten billion with a B dollar study contracts to come up with nothing. And that's what they're going to do. They're going to say, we need more money. And they're going to start exaggerating the threat. And they're going to start talking about, there was an incident off the coast of the Kingdom of Tonga where a dolphin got hit by something. And the New York Times is going to go, threat to our seas. There is a tremendous possibility of damage, though, because of overcrowding in those orbits. Now, okay, we've got inclination, which is orbiting not exactly around the equator, but inclined up and down 1 or 2 up to 50 and 60 degrees. Inclination frees you of some of the dangers of debris, but it's like a highway. There's only a certain amount of density that can be accommodated. And when Starlink puts up another 13,000 and Kuiper puts up its 3,000 or 5,000, and then you've got 100,000 hostile enemy satellites up there, all of which eventually run out of gas and start going chaotic, you're going to have traffic jams. You're going to have situations like one car out of 100 on your freeway runs out of gas suddenly, or the ignition just cuts out, and bam, and people are trying to, you can't avoid it. The only way you can avoid stuff in space is to have hours and hours of early warning. And even then, it can be very tough. So that part of investment it'll be one part wasting money, which is what the defense contractors are best at. And it'll be one part serious science about creating regulatory agencies. The ITU is one of them, the International Telecommunications Union, which regulates all satellites and all frequencies, to have the teeth to say, okay, Starlink object 22A or whatever, just seen interfering with the flight path of NASA bird X. And it's damaged. Starlink, hand over the money.
All right.
We haven't got anything like that.
Yeah, but thanks, Brian. We got 5 more minutes, and we want to make sure that we have some pictures and photos with the GATE team and in the thing. So we got to do one more. We got one more question here, and as you can see, I'm an undergraduate in the comments there.
Ah, okay. Iranian, I think. Iranian, I should say. Undergraduate engineering student is wondering if you could give me some tips how to get involved in an aerospace career. For the first one, you're doing it right now. Get into podcasts, look up NASA on LinkedIn, and start connecting with people who have soon to be engineering background. You're interested in aerospace and space, but I'm a horrible student. Sounds like me. How can I carve a career that I enjoy despite my lackluster grades? HR people have not created yet another pernicious, heinous practice of insisting that your metric for success is your GPA. Anybody, particular senior folks like me, can tell you that's a bunch of nonsense. It's a good indicator for grad school because it shows you whether or not your willingness to do the grinding that you've got to do for graduate programs, but it's not an indicator of intelligence. Some people are ADHD like me. It's very hard for me to focus on anything. I'm like the next shiny thing. And what I've trained myself to do, and especially the people around me, is, Brian, you got to get that design done today. So I go, okay, that's all I'm going to do. I'm not going to get up and watch the news. I'm not going to make a 12th cup of coffee. I'm not going to chat with my friends. That's what I'm going to do. So hook up with people. Hook up with people. Don't think that just because somebody is the head of human spaceflight at NASA that they won't. They're on LinkedIn because they are interested in communicating. There are plenty of people on LinkedIn who just want to talk, and there are plenty of people who want to explain to you why you have to hook up with them as recruiters. Ignore that. Find what you're interested in and get into discussions. I have, I think, 9 or 10 of my former students, 10 years later, we talk all the time. Just do it. Don't think about it. Just start connecting with people that you are interested in.
Brian mentioned one of the most important things is enthusiasm. So
Yep.
Enthusiasm. Okay, I think we're gonna get to some photos and stuff. Brian, thank you so much for joining us today and speaking with everybody here with Gates.
With me.
We got Brian's email, and also it's Brian Zetlin on LinkedIn. He's very active on there when maybe he should be focusing on that one project. But anyway, so really great to have you on here, Brian. You were a gentleman and a scholar, and I'm glad to consider you a friend. Thank you for all your support, and I look forward to our future talks. Thank you, everybody, for joining, and hope you have a great day. Make sure to connect with Brian. Go check out Solis, and yeah, onwards and upwards in a space thereafter.